In this video, we're going to talk about how to solve right triangles by using the trig ratios we learned earlier, sine, cosine, and tangent. So I need you guys to flip over your paper first, because we're going to start on the back side this time with the harder problem. At the bottom, we're going to write down our phrase. You cross out that critical thinking. The phrase that we always use is so, ca, to. If you remember, S is for sine, the O is for opposite, and H was for hypotenuse. So that meant that the sine of whatever angle we were using was equal to the opposite side over the hypotenuse. C was for cosine, A was for adjacent, and H was for hypotenuse. So that meant that the cosine of the angle, theta, or whatever it is adjacent over hypotenuse. And our last one, TOA, O was for opposite, A was for adjacent, so that meant that the tangent of theta, our angle, was equal to the opposite side over the adjacent side. So if we go back to the top, we'll do number 9. Remember, we always label our hypotenuse first, which is always across from our 90-degree angle. So this is my hypotenuse. And now we're using this angle of 55 degrees. So if this is the angle I use, then the opposite side over here, the 29, is going to be labeled as opposite, which means that this x must be the adjacent side. Now we just have to set up our ratio. So we have to figure out what we have and what we want to have. So we want to have this x here, which is adjacent, and we have the opposite side here. Now if we go back down here, we need to figure out which ratio uses opposite and adjacent. Well, that's going to be tangent. So that's the ratio we set up. So we have the tangent of theta equals opposite over adjacent. We have opposite and adjacent here. So I have tangent. The angle I'm using is 55 degrees. And it's going to equal the opposite side, which is 29, over the adjacent side, which is x. Now we just solve for x. So to undo this x here, I'm going to multiply by x on both sides. So now I have x tangent of 55, where the tangent of 55 is in parentheses, that equals 29. Well, now to get rid of this multiplication here, I have to divide, because the inverse of multiplication is division. So now I have x equals 29 divided by the tangent of 55. Now notice I took the whole ratio tangent of 55 when I divided. That's why I put it in parentheses here. So don't just take the 55 as the number. I know you guys are used to that, but now you got to take the whole ratio, because really the tangent of 55 is a number. If I typed in tangent of 55 in my calculator, I get a number out. It's 1.428. So if you wanted, you could substitute that in and put 1.428 here. But it's definitely faster to just write tangent for 29 divided by the tangent of 55. So x equals, I'll punch this in my calculator, 29 divided by the tangent of 55. I get 20.3. So that means that this length x equals 20.3. We'll do another one. Let's look at number 12. Across from our 90-degree angle is our hypotenuse. My angle is 21 degrees, so across from that is the opposite side, which means this up here is the adjacent side. Now again, I want to figure out what x is, so I need the opposite side, and the information that I have is this hypotenuse here. So I need to figure out what ratio uses opposite and hypotenuse. If we look at our notes, opposite and hypotenuse, that's going to be the sine ratio. So when I set this up, I'm going to have the sine, my angle is 21, equals the opposite, which is x, over my hypotenuse, which is 22. Now I just have to get x by itself, so I multiply both sides by 22. So I have 22 sine of 21 equals x. And I'll just punch this in my calculator. Now, if you remember from the last video, you do have to make sure that your mode is in degree. So just hit your mode button and then go to degree. Now I can punch in 22 sine 21, which is 7.88. So x equals let's round to 1 decimal, so it'll be 7.9. And that's our answer. We'll do a couple more. Let's look at number 13. Across from our 90-degree angle is always our hypotenuse. My angle is 33, so across from that is the opposite side. And so this means this last side is the adjacent side. Now I have to look at what I have and what I want to know. I want to know this opposite side, and I have the hypotenuse. So again, I ask myself, which ratio am I going to use? Well, opposite and hypotenuse is sine again. So we're going to use sine. This time my angle is 33 equals the opposite side, which is x, over my hypotenuse, which is 29. To get x by itself, I have to multiply by 29 on both sides. So I have 29 sine of 33 degrees equals x. So I'll put that in my calculator. X is 15.8. We'll do one more. Number 16. Across from my 90-degree angle is my hypotenuse. Across from the angle itself is always the opposite side, which means this 34 over here is the adjacent. So I have the hypotenuse that I'm looking for, and I've been given the adjacent side of 34. So adjacent and hypotenuse, if we look at our ratio, is the cosine. Adjacent over hypotenuse. So I'm going to take the cosine of 59 degrees, and that's going to equal the adjacent side over the hypotenuse. Again, to get that x by itself, I need to multiply on both sides. So I have x cosine of 59 equals 34. This is being multiplied, so it's in parentheses. So to get rid of that, I have to divide. So x now equals 34 divided by the cosine of 59. I'll punch that in my calculator. And you get 66.01. So x equals 66. So I want you guys to try the rest of the problem.